Hey, hello, welcome to the show. It's me, John Park, and it's time for John Park's Workshop. Thanks so much for stopping by here today. We've got all kinds of fun stuff planned. By we, I mean me, planning some fun stuff, including a coupon code for you to save some money at Adafruit, a recap of the product pick of the week, a CircuitPython Parsec, a new project, and some recaps of or status updates on ongoing projects. Also, a Rhino Grasshopper 3D modeling CAD tip tool of the day training thing today also. So thank you for popping in over to the chat. We seem to have YouTube streaming and a few others, but I know something's going weird with Facebook, so sorry to anyone who's trying to watch over there. But this is our chat. If you are one of those places other than YouTube and you're wondering where the chat is at, you can join us over on our Discord server in the live broadcast chat channel, and the server is available just by going to adafruit.it/Discord, and you'll get an instant invite so that you can hop on over to our channel. Thanks, Thin Man, for stopping in. Squid.jpg, hello. Jim Hendrickson, John Nodge, howdy. C. Grover, Andy Calloway, thanks for stopping in. One thing I want to actually, since this just reminded me, I just saw Squid.jpg pop up over there. The learn.adafruit.com playground, I saw a guide that Squid.jpg posted. I've been meaning to check it out. So this is a zapper, a Nintendo light gun sound mod. So these are mostly useless if you don't have a retro console and a CRT. So Squid.jpg made theirs into a prop pistol, which is pretty cool. So go and head over to the learn.adafruit.com playground, and you'll see it's listed up there at the top. Really cool, bunch of 3D printing add-ons to make it all complete. But this has sounds, this has battery, this has light. This is super cool. So thanks for posting that, Squid.jpg. I'll take a closer look at it later. I don't know if I'll harm my existing one, but I do see boxes of these zappers. This is the one I have, is this gray one. I do see boxes of these at retro game trade events and things like that. But that's the old light gun. So zapper mod, very cool. Thanks for sharing that, Squid.jpg. What else is up here? I mentioned coupon codes. So if you want to go over to the Adafruit shop and get yourself some stuff and save some money, then you can use this coupon code right here today until midnight tonight East Coast time. It is a little hard to see there. Jankytronics. No, Jankymatronics. I went back and forth. Jankymatronics. This is Janky Animatronics, but I'm mushing the words together. It's Janki, Janki, Matronics, Matronics. I'll leave that up for a minute because that's not one that just immediately is apparent how you spell it. But you can use that coupon code over on the Adafruit shop for pretty much anything that is physical stuff that we can put in a box or an envelope and ship to you. That will not apply to software, gift certificates, or subscriptions. But if you want to buy some things, some cool stuff for your projects, then load up your cart, and on the way out, look for that coupon code slot and type this in right here, Janki Matronics. Also, since I'm talking about the shop, a couple tips. You can head to the products, view all new products right there, and that will show you all the latest cool stuff, including this nice upgraded, updated Pi 2 touch display, or Pi Touch Display 2, which is a nice little 7-inch touch display for Raspberry Pi projects. It connects with a ribbon cable directly to a Pi 5, maybe 4, maybe earlier, not sure. Don't have to use HDMI plugs, so you can keep your projects nice and neat and compact. And now it's a 1280 by 720, so a higher resolution display. It's got cap touch, so it's nice for those cases where you need to fire up a Raspberry Pi, have a display, have minimal interface without plugging in a mouse or keyboard if you're just having to click on icons. You can, of course, still plug in your mouse and keyboard. But anyway, that's a neat new one. That's $60, and that will cost you $54 if you use the Janki Matronics coupon code. And that, of course, is true of anything you see here. So we've got a new pressure sensor, some pixel shifter for RGB LEDs that want 5 volt and not 3 volt. We've got a whole bunch of other cool, neat stuff in here. Additionally, if you want to buy a bunch of stuff, head to adafruit.com/free so you can see what the current enticements are. Basically, if you spend a certain amount, you get a free thing. If you spend enough more, you get the first free thing and the next free thing, and so on. So you can get a PCB coaster at $99. You can get a KB2040 at $149. If you spend $199 or more, you can get the UPS free ground shipping in the continental US. And if you spend $299 or more, you'll get a CircuitPython Express and the ground shipping and the KB2040 and the coaster. So all those stack at the different levels there. So that's the coupon code for today, Janki Matronics. I'll make it easier to read there. Go to Adafruit and check it out and get yourself some stuff. Save some money. Who doesn't like to do that? All right, let's see. What else do we have going on? My Tuesday show is the Product Pick of the Week show. I had a pretty snazzy little IR transceiver on here this week. And during the show, that show happens on Tuesdays, this same time slot on Tuesdays, not Thursdays. And when you tune in, the show is broadcast from within a project page, a product page that I will reveal and is in the blog link. Not only does the show appear in the page, which is fun in and of itself, but we usually slash the price in half. If it's an Adafruit product, we have the margins to be able to sell off a group of them at 50% off. And this was the product pick this week, along with a little 1-minute recap, so check it out. It is the infrared IR transceiver breakout. I have a Feather RP2040 plugged into pins 5 and 6 for data in and out are 2 of these IR transceivers, and then they're also plugged into 3-volt power and ground. If I press red there, or green there, or blue there, both receiving a signal and turning them one of these colors. So I have received blue on one of these. I covered the other one up. And then after a moment, it turns off and resends whatever message it just received. Since they both have identical code, they're just going to send this little message back and forth forever. Pink there, so waits, sends. This one's going to receive, then it's going to turn off, send. This one's going to receive, turn off, send. Off, send. The infrared IR transceiver breakout. Yes, indeed, that was it. If you get 1 or 2 of those and make some cool project, why don't you write it up on Playground? I don't know if I mentioned this before when I was showing off the cool light gun project that squid.jpg created, but here at the top, I think you can see it. Yeah, it says adafruit-playground.com. You can just go there, or you can find it through the menus up at the top. Playground, anyone with a email address with Adafruit, I think that's all you need is that sort of account, can create their own guides here. And we have a learn guide about how to make them if you're wanting to read up on the instructions before you do it. But you can see here, there's the My Playground link, there's the Create a New Note link, and you can go and build using some of our tools that we use for our own learn guides internally. You can use those tools to create some documentation, which is kind of neat. So, all right, next up, let's dive into a CircuitPython Parsec. CircuitPython Parsec. For the CircuitPython Parsec today, I'd like to show you how you can use a touch display and vector I/O to create a circle drawing program. So this is a very simple drawing program, and maybe I'll be able to extend this to some other shapes and styles of drawing tool. But since we've been looking at these little cap touch or resistive touch displays, this one happens to be a Pi Portal, but this would work with any of our TFT feather wings and other breakouts as well. We have a little display there. We can record the position and the pressure when we touch the screen, and then we can use that for stuff. So at one point a few weeks ago, I showed how to determine the distance between 2 points. Then I showed how to draw a little circle wherever we touched. Now we're going to combine those things, and we're going to place a point on the screen for the center of a circle, and then we'll place a second point to determine the radius of the circle, and then we draw the circle. So you can see I just have to touch once and twice, and I'll draw my circle. So the way this works, if you look in the code here, in CircuitPython, I'm importing a bunch of libraries, including the vector I/O, which is responsible for drawing the shapes, and the Adafruit touchscreen library. We initialize the display, and then I'm creating a color palette for those 3 colors. I am setting up 3 circles. One I'm calling the center point, one the edge point, and one the final circle. And actually draw those on the edge there at the beginning when this first starts, just so we see some little 4 radius circles. And then I append those to the main group of the display, starting with the circle, so that's at the bottom, and then on top of that the edge and the center point. And that's just that we can still see things since they're drawn sort of in layers on top of each other. Then we initialize the touch screen. I have the same little formula we used before to determine the distance between 2 points. And then I set up some empty variables that will fill as we go. In the main loop here, you can see I am checking for the screen to get touched using touchscreen.touchPoint, and I cast that into a variable called PT. And that'll actually be a tuple that'll give us the X, Y position and touch pressure. Then if the first point versus the second point is being touched, I can check with this right here by checking the state of that variable. Then I will create a variable called PT1 that is that original set of the tuple. And I'm going to go ahead and hide any existing circles by moving them off to the edge. I draw this new circle by grabbing the touch points X and Y positions. That places it somewhere on the screen. And then I have a little sort of debounce moment there, half a second to wait before I touch it for the next point. And then with the second point getting drawn, I am again placing another dot. You're going to see that show up. But then a moment later, this happens. I find out the distance between those 2 sets of X, Y coordinates, and then I create a new circle that has the first set of X, Y as its center, and the second set of X, Y as the radius of it, the distance of it. And then we sleep and repeat. So we can go and draw new circles. We can even make it look like we're dragging to create them by just waiting a moment there. Boop, boop. And that is how you can create a circle drawing tool inside of CircuitPython. And that is your CircuitPython Parsec. CircuitPython Parsec. So yeah, we're basically going going to build a vector drawing program here at some point, I'm sure. It might be a little slow to try to draw Bezier curves and things like that, but you can imagine this can be extended out to some of the other primitive types that are available in Vector.io, including I think we have a rectangle, a rounded rectangle, line, and just a point. I could have used that instead of the circles, but I had those already set up for use. And do some other neat things like adjusting color, borders on things. I think Vector.io can do just an outline version of this. I think it has an edge and a fill, or an outline and a fill. So it would probably be a lot of work to work this up into a drawing program you'd actually want to use, but I think it's kind of fun to look at the little elemental bits and pieces of a drawing tool. Okay, Andy Calloway says that's a well-rounded parsec. Thank you. John Nodge, also hat tip. Okay, next up, what are we doing here? I've got a couple things. What are we going to look at next? A couple updates. So just so we don't forget about them, I am still going to be working with some of the DMX stuff that we looked at last time. I actually ended up using these for some Halloween lighting, the DMX controller, and some little pre-programmed sequences. So I'm going to do like a basics guide just on kind of the basics of DMX and using an Arduino Shield for that, and then we may try to push that further and make our own product, maybe a feather wing, a DMX feather wing. If you are curious about that, Lady Ada did a great search on the last desk of Lady Ada of looking for the little XLR, 3-pin XLR male and female connectors. So she's going to look for something that's a right angle, through hole, solderable, similar to the way our little MIDI feather wing works probably. And then maybe get that running under CircuitPython. But if not, we'll have a pretty cool feather wing for using on a feather that can run Arduino, which is most of them. So let's see what else. So that's some DMX stuff there. I'm also working on the Game Boy game, and let's see. Can I give you a little preview of? I started adding some artwork to the levels. I just have 2 rooms, 1 level, 2 rooms. But they were looking pretty bare, and I decided to spend just a little bit of money on itch.io, where you can find a lot of great art asset packs, and started dropping in some existing furniture and things like that. So I'll open this up and then I'll share it with you once I find the right project file to open. Second. Okay, so let me switch the view to this little capture view here. Get that out of the way. So this, if you recall, is the GB Studio, and I've got a couple of rooms here that we go into, and you can see now a lot of the screen is blocked by just blockers. I don't want you walking through furniture. But you can see I've set up some little plants and windows and bookcases, and Lars is hanging out there. I recrafted the Lars sprite there. I like him better. Got a little couch and a TV and a N64 sitting there, a little table for our drink. And then the second room here, let me see, I think I can just turn off the collision objects and make that a little easier to see. So here's the little bedroom now, and we've got a little closed closet, a Pokeball, a little computer sitting on a desk. So these are all little sprites that I included in my single sprite that I had made, little four color pixel art room, and those are basically all baked in. So usually this sort of stuff is baked in. Repetition is good because you only have a limited budget of the tile set that can be used. So that's why you'll see a lot of repetition in this kind of game. If I hit the play debugger here, it's going to compile it and open it up in a little sort of emulator debugger. I don't have my hardware with me today to show it on, but I may have to zoom in on this screen because it's a pretty small little screen there. Oh yeah, you can see that pretty well. So here's my little intro screen. Dorky Demustard. Hit play. So here you can see all those little collision objects are why I can't walk through. I can walk through and kind of across the N64 there, just because I didn't want to block this whole area. But you see I can't go through the couch, go behind it, but not into it, and we can't sit on it in this game. We can go and talk to Lars now. And he's got a little avatar that shows up along with his dialogue. And it tells you what to do. And then you can head over to the other room. You can kind of explore stuff around it. I'm, limited by time budget on this, so I don't really have a lot of things that are active in here. But when you run into your battery, it says, "Hey, battery's nice." And I also add an event where, if you look, there's a cassette there, and that's gonna fall off of the little shelf there to make it obvious that that's what you should go and get your cassette tape, and then you can head back here and play our song, which I'm just making that one little mini loop of it. I'm not creating the whole song to, again, avoid trouble. So I'll close that out with copy strikes. Okay, so that's the update on the Game Boy game, and I've started writing up a guide on that, and I'll include the game. You'll be able to get it as a GB Studio file. You can open that project and all the artwork. I will include a link to the art pack that I got on itch.io. That's something I purchased, so I'm not including that other than what's baked in here, and that's okay with the terms of the license for that art pack. And then I'll include a ROM and a .pocket file if you just want to throw it onto a SD card and play it on an analog pocket. And the ROM you can open in any software emulator or put onto a physical cartridge like I was showing last week. So that's our Dorky Demustard update. And for those of you not sure what the heck, why am I doing that? There was a Green Day album that came out where each song was on a different different obsolete format, and one of those was a Game Boy cartridge, but they only made 25 of them, so I decided it'd be worth learning how to use modern tools to build a Game Boy game and put it onto hardware. So that's what that's all about. If you're curious, why is he doing all this? Okay, let me take a sip here. And let's move. Oh, you know what? Let me highlight some discussion going on. Someone asked about doing vectors, continuing the discussion about vectors in CircuitPython. Some nice asked about it. Toddbot wrote, "Yeah, I usually create my own class. I think I've seen people use NumPy or Complex to do vectors." And then some nice included some code for Node.js. With some more vector stuff. So if you're interested in the vector conversation, head on over to our Discord and check it out. Right. So next up, why is this Jankimatronics? Why is Jankimatronics the coupon code today, you might ask? Well, I found out about this recently, about this very cool bit of animatronic rigging and animation software called Bottango. I think I saw it on the MakeZine newsletter that I got in my mailbox, as well as a couple other articles. Someone did one, I think, on Hackster, and maybe someone did one on Hackaday or somewhere. So I started seeing this around, and this has been a project that's been ongoing for a number of years. I don't know if they had a major release recently or why it kind of came into my consciousness and was showing up all over the place, but as you can see here, there is a 3D model in the software that has a graph editor for setting animation keyframes and interpolation. And the cool thing, I don't know if they have a GIF, yeah, this should show it. Here is a real-world object of this little parrot. They actually sell a kit for this that is being animated with the software and is being puppeteered, moving in real life using servo motors and linkages and some clever building techniques. This is like a flat pack laser cut wood, I think, with stickers or paint. And they have a kit for that. That might be worth checking out, actually. So the main cool thing going on here is the ability to animate servos and stepper motors with intuitive tools. And if you saw the show and tell last night, I showed off this little quickie rig that I put together. I'll show it here for context, and then we'll look at it through a close-up camera. But you can see I've got 3 servos that are connected to each other, and I put a little styrofoam pumpkin on top there just to give it some character. And when you put together, this is the sort of quickest, easiest way possible. Normally you'll use 3D printed brackets or purpose-built brackets to do these types of rigs here. So you'll see here's one I got many years ago. I forget who made this thing. Robot Geek. So here is a servo with another servo mounted to a cool little bracket, and then that servo has tilt. So this is a little pan tilt, little 2-axis kind of thing. Similar to, we actually have this micro servo gizmo, and I did a little learn guide about this project a little while ago. So there's a couple of servos, and they can, again, pan back and forth and tilt up and down. And so that's a linkage of a couple of servos, and that's what you get your typical mounting setup when you're first getting started with these. But the question is always, how the heck do you animate it? You can set some, programmed values that you trial and error it through, or you can let it take by example. So that little setup that I have there, I dial it in and then save keyframes, but I'm physically dialing it in with a couple of knobs. And so the cool thing with this Bottango is that it is able to stream the animation data from the computer, from the software, to a microcontroller running Arduino, and then drive the servo motors or stepper motors. So let me switch my camera view up here to give another little layout overview here. And I'm gonna grab a little light here just to put some more light on this. So here's a view of my rig there. I'm going to just adjust some of the camera settings here. It's a little white balanced, funky. There we go, it's a little more natural. So you can see these are 3 individual steppers. I just used some little U-glue dots on them to connect them to each other, which obviously it moves things off axis. Ideally you'll build little brackets to get everything in a proper line if that's what you're looking to do. But I have a pan here, a tilt here, another pan here that allows us to move this around. And if you take a look at the software here, let's see, I can make this a bit bigger. You can see I rigged together the same sort of setup here. So what I have are 3 joints. Those are the purple things there. Let me go over to the build module here. So when we're putting this together, we've got joints that we can create. So there's joint 1, joint 2, and joint 3. That's my hierarchy. It's a parent-child relationship. So anything the parent does, both of the children follow along. Then if I move the second item there, it's the parent of only one thing, and the last one is only a parent to the pumpkin sitting on there. So I have this 3-joint hierarchy, and then I also have a corresponding motor. So the way I put these together, here's joint 1 down here, and it is going to rotate on the y-axis. So that's a little simple setting that we can create there. And then we can associate a motor with it. And we can do things like, if you watch my, let me move the camera view here. So if you watch that little camera view there, I think you can see that pretty well. If I click on these little settings in the software, we can test the pulse width modulation values used to get to different range of motion. So most servos are somewhere under 180 degrees of these hobby servos. Most of them will go 80 degrees one way, 80 degrees the other way, or more or less depending on the pulse width signal you send to it. So what I determined with these is that sending a 500 gives me this first about 80 degrees in one direction, and 2500 gives me 80 degrees in the other direction. So I've set those up and linked those to the joint so the joint can control that motor. And then over in the animation view here, if I grab this joint 1 and start moving it, you can see my rig follows suit there. And you can see it's actually very responsive. This is going from USB to the, I have a Metro ESP32S2, and it is connected. On top of that is our PWM driver shield, 16 servo PWM driver shield. So it's talking over I2C, but it's all working really responsive, really fast. So I'm pretty happy with it. So then the next item in that hierarchy, if you look at the build, here is joint 2, and that is rotating on what is considered the x-axis, around the x-axis of this world. And I have a motor that I've kind of rotated to suit, set up its range, connected those together, and then over in the animation view, again, I can test that and see what will happen. And sorry, I know this this camera view here is a little. Let's see if I can shrink that down. Am I here? Oh, there you go. That shows it a little better. Yeah, let me just. There we go. Can move that, and last one is the joint 3. Same sort of thing. We have the extents that can go. We can also set the speed, the maximum speed of something. So it's one thing to say, hey, how fast can a servo rotate on its own, but it's a whole nother thing when we start to connect things to it. So as you have physical parts on your animatronic, or in this case, I'm carrying the weight of 2 more servos for this first one, and the pumpkin, which is actually styrofoam and pretty light. You have to account for these things. You can't make things move immediately from point A to point B. Physics is going to get in the way. So you can, through some testing and trial and error, actually tell an individual actuator or motor what its maximum speed is. And in this case, the maximum speed is 3,000 PWM per second. So you can go faster than that on a empty, unladen servo, but if you start carrying the weight of some other stuff and connecting it to things, you'll start to tune that. So there's some nice settings in here. There's also a couple of things to fix your visualization if it's moving left when it should be right in the software, but the real world's doing the right thing. You can change some of these horn visualization settings. The horn is the name of that little piece that's connected to the axle on a servo. So again, if I go over to the animate section here, and let's, I'm going to expand this view a bit. You can see I have 2 possible animation timeline environments or editors here. One's called a dope sheet, and the other is called a graph editor. And these are dope sheets are very similar to a kind of horizontal version of a timing sheet from traditional animation. And they just tell you where in time a keyframe is, but doesn't tell you anything about the value of it. It's good for spacing and getting an overview of the timing. But the actual values and timing are easier seen in something like graph editors, a bit more modern. These came into being with computer animation more than traditional. And you can see if we look at, let's say, just the y-axis here, the second joint 2, which is rotating on x-axis rather. If you look at this one, actually it'll be easier to look at joint 1. How about? Okay, so if we look at joint 1, so just think about this base twisting joint. I have a keyframe that starts at kind of at its home position. So in Bottango terms, that's at 0.5. It can go down to 0 and up to 1. That's the full range of sending values to the servo. It will turn to the left as it goes towards 0, and then it will turn to the right as it goes towards 1. And you can see when I play, I'm just going to play this section here. How about to there? If I play just that section, notice how it eases. It slows down as it gets to the extents, and you can see it in that shape. We have kind of no change, and then it dips, and then it eases, and then it eases out and eases in. So all of those soft curves give us this slowing down as we reach the extents. If we want it to look more harsh, like it's bouncing, we can, let's take just this bottom one here, and I'm going to break. Oh no! I'm gonna crash Bottango. Let me reopen that. I'm not sure why I didn't like that. There we go. 3 servo test. Let's see if it actually maintained connection to the hardware. It's acting like it did, but it has not. Let me try to I'll reconnect the motors. So this is kind of neat, actually. You can see here. Here's what's involved with, once we have the proper firmware on the microcontroller, we then need to establish a connection between the computer and the microcontroller, and that's done by picking the serial port. So this right here is a list of possible serial ports. I can select that from the list. It's actually got the right one here. It's this one showing up as TTY USB modem 146.14401. So that is the list of possible serial ports that you can connect to. And so once we're connected to that, we should have the ability to control those again. So I found it's pretty reliable. In fact, that was the first crash I've seen there. So let me go back to the graph editor, and I'm going to go back to this joint here. And let's see if it allows me to break the tangency on this or not. It did, and it didn't crash. Okay, good. So this allows me to just change this shape of this curve, and now it should actually accelerate as it turns in and out. So it's going to be a bounce-like motion. So I'll just go here, and I'm just going to set the playback range. Boing. Boing. All right, so you can see that any sort of standard CG animation tools, which you can learn these in Maya, in 3D Max, in Blender, any typical 3D animation workflow is going to include this type of a graph editor. And now you can apply all that info over here in a servo and stepper driving tool, which is super cool. And this is, of course, not limited to one servo at a time. So I just happened to have initially a test of each axis on its own. So if I play this up to, let's go to here. It will move just joint 1, then joint 2, then joint 3. 1, 2, 3. What I've done on the second part of this is go ahead and do some coordinated movements. So let's hit play over here. Actually, I don't love that. I didn't save the stuff that I showed yesterday, which was a little better. So let's go ahead and fix these. What I can do is, let's just start here. And okay, so we're bending back here, we're waiting, we're headed over here. I'm not going to go that far, so let's see, this is the joint 1. I can bring this down, and that means we're headed not as far in that direction, not all the way to 1. And so let's go to that keyframe there, and let's say we want to, my little adhesive is coming off. Say we want to tip back during that too. I'm going to grab this joint and bring it back this way, so you can do it with direct manipulation, or you can use the keyframe tools here. You can smooth that out if you want. You could get rid of that keyframe too. And that's where it ends there. Okay, so let's stop right there. And now we can just play back that little section. So we have a little coordinated move now. And sorry, I know the ball in the demo there is not a pumpkin, and I had stripes on it before we crashed, which made it a little easier to see where it was facing, but it's a perfect sphere, so you can't really tell. If I wanted to fix that, I'm going to come over to the build view, and there are just a few things you can create: a cube, a cylinder, and a sphere. So I actually added a cylinder and made a little stem to start with. So we'll scale this thing down here. I'm going to parent it under, let's parent it under the ball geometry. And then if I zero its position out, it should go to the center of its parent. So I'll go 0, 0, 0, X, Y, Z, and then I'll move it just up on Y. There we go. And then I can also rotate this a little bit. So there, that'll at least help me see rotation. And we can do things like color stuff. There's some simple tools for things like that. So if we go back over into the animate view, and I'll zoom out a bit further than I was before. Now you can see even just the spinning rotation on that ball a little bit better because it has some reference point that isn't just the sphere. Okay, so let's see. That is some of the basics of it. It also has some more advanced features that I haven't looked into yet for inverse kinematics, which allows you to coordinate the rotation of multiple rotations, multiple forward kinematic rotations, by setting the position of an end effector. It basically does the computation of if I have, let's say, my arm here. Let me hide this thing for a second. If I have my arm here and I want to go like this, normally we would have to rotate the shoulder, rotate the elbow, rotate the shoulder. Oh, that's where we want it. And then to bring it back down, rotate, rotate, rotate. Inverse kinematics works by saying what's the position in space that we want to aim a target at, and it solves the rotations of that joint chain to make the end effector point at that target. So inverse kinematics, super useful for limbs in particular. And then this also seems to have some blending between poses. It doesn't really have a generalized aim constraint, but I think you can do, like with our little pan tilt here, we can do things like create a little UI for dragging a point in space, and it'll seem like it's aiming at it, which is great for eyes because we're trying to coordinate two axes to look around with eyes or heads. So looks like it has a pretty neat tool set, really impressive. I will also mention this thing has an open source API and firmware. The app itself is not open source, it is free. At least right now it's free. But the if you go to, let me go back to this here, if you go to, where is it? Bottango. Yeah, it's github.com/Evan Bottango, EVAN, BOTTANGO. They've got the Arduino driver, network driver, and a playback control API, so you can create your own user interface or programming solution that can then talk to the microcontroller that's driving the whole thing, which is really cool. Super impressive, really nice. So that's kind of the basics of what's going on with that. What I wanted to do next was look at a possible janky Matronics real-world use for this sort of thing. So let's head over to the workbench. And you can see I got this little weird guy here that I picked up at the hardware store last night. And let me just open up my Discord chat here so I can keep an eye on things. So this little guy here, let me turn off this air for a second, is like a $25 animatronic from the hardware store, and let's look at it from the front view. So I can set him. Get this out of here. Set him like this. So I've started to remove some of his clothes and stitching, but we can still show him in this use. So it's got a, hopefully this doesn't get copy striked. I'll just play a little bit of it. It's got a licensed song, and what you'll notice is when I play, it actually has two functions. It has a side-to-side twist of the torso that seems to cause the arms to do this. So there's a link between those. I think that's one actuator that has these two things going on. And then it has a second function where sometimes it lifts the arms up. So watch this here. So you can see the movement's happening at the waist. I'll stop that and restart it. But it's also sometimes, but not, it's not locked as a single function. So that could be two motors. It could be two motors in there. They're not going to be servos. These are going to be DC motors, almost 100% guaranteed, and just a very clever linkage mechanism to do that. So what Lamore asked was, okay, it's going to be super janky, but if you take something like one of these little holiday animatronics and find a way with, drilling and hot glue and however to get a couple of servos to drive some of these motions, can we program it to do our own thing? So in a case like this, just to not be too ambitious, I would expect to be able to maybe do the arm raise up and down on command and run it from the servo whenever you want, program it with the software, and then the side, turn to a side, which, as you can see, there's a corresponding arm movement that you can't get away from with that. So let's take a little closer look inside of this little funny boy here. I'm going to move this demo out of the way. So I got rid of the hat and glasses, and these are all just sort of simple stitched on. Yenisku7 says, Yars hosted Jankyard Wars. Oh, John Nodge posted a Jankyard. I used to love watching Junkyard Wars. That show was awesome. So here's our little guy here. I've started to unstitch it here, and we should be able to, I don't want to unstitch it too much, we should be able to peel off. So there's the head. There's the head off. There's just a little fluff in the wrists and a little wire for the hand. Nice. And actually, if you don't mind, since I'm taking pictures for this for a potential learn guide, I want to take a picture of this partway disassembled state, since I haven't, I didn't take a picture of this far. I haven't been this far into the Frosty yet. Oh, poor guy. It wouldn't surprise me if the company that makes this is able to put a whole bunch of different stuffed animals, whatever you call these guys, plushes around this. Oh, that's interesting. This took a bunch of strain and stress in the store, probably, of people walking by and twisting its arms. And then with the feet here, sometimes these will have a little, I feel a zip tie in there, yeah. So sometimes these are cinched together with a zip tie at the bottom and then stitched over that. It's possible taking off these screws will get us a little easier access to that. So let's do that. Let's pull out those screws, and I'm going to get something to put them in. So there's a battery pack, it looks like, in each foot. Let's see, are you really a battery pack? Interesting. Yeah, it seems like maybe there's 3 batteries and they put 2 in one foot and 1 in the other. See how those are different sizes there? That's interesting. Let's see if that's really what's going on. I'll open the battery pack first before I remove that. Yeah, so there's one. Oh, wow, it's a Duracell. Amazing. It's not just a generic. I guess part of the thinking there is that these things are actually usually weighed down by their batteries. That's part of what keeps them standing when they're jerking around doing their little dance. And off-brand batteries weigh nothing. Like if you ever gotten a battery that's going to last 10 minutes when you get it, it does not weigh much. I keep threatening to get a replacement for the little electric screwdriver I had so that I can do this faster. Maybe this is the year. All right, let's take these batteries out too. Yeah, so this one probably had a little plastic that was removed by someone at the store so that you could run the thing. Yeah, look, Duracells, amazing. Or they're fake Duracells, who knows. Okay, so with that loosened up, again, pardon the interruption, I'm going to take a quick picture of that. We can remove that, loosen that battery pack base, and then peel the foot off of there. I'm betting we're going to have to still cut a zip tie, but maybe not. No, okay, cool. Well, that's nice. So we can leave that. Oh, I missed 2 screws here. Can leave that in place. And probably skin it fully, which would be a lot easier to work with. So here we go. Like so. That one does not have as much slack to the wire for some reason. It could just be something that's caught up in here. Oh, it's that hot glue. So some hot glue there, holding that from moving, which is probably wise. I'll see if I can work with that. All right, time to pants the snowman. And the other side. Someone, I think, mentioned earlier before the show even started that maybe we're going to see some Lars animatronics, which I think would be disturbing and fun. I don't know if he'd fit this, but it seems close. Some of you may know my Lars actually does have audio in there. Actually, yeah, he's pretty similar size, isn't he? Could be interesting, Lars. Could be interesting. All right, so it looks like the feet just are screwed on just to put the parts together. And yeah, you can see the arms have a I guess the arms are driven by the motor. I wonder if they're reaching a point where they now have to go up before they do their next thing. Because I feel like there's like a little gearing or escapement or something that causes the hips to go. And it's almost like it is a certain number of times that ratchets this around to where these go. Let's see. 1. Okay, it's locked. 1, 2. Oh no, maybe it's not. We'll find out. So let's take a picture of naked snowman here. And by the way, where's the switch on this guy? He's got right there. You won't be able to see it too well, but there's a button right there. That's what actuates him. So that's this pair of white wires here running up to the board. And let's see if we can pull off the chest cover and see what's inside. Andy Cowley says, Snowman's got a serial number. Yeah, that's kind of dystopian, isn't it? Let's see, are you the same screw? Yeah, let's hear it for using the same screws throughout, pretty much it seems. These are the same ones that held the feet on. I just helped a friend of mine fix a damaged synthesizer keyboard of his that was damaged by a incorrect case screw. One of the long case screws from one spot got re-screwed into a spot for a short case screw, and it actually just managed to ding up the PCB enough to cut 4 traces on the PCB. So we bridged those and got it working again, but it is diabolical when there are some different screw length differences when you're reassembling things. I'm being sort of casual here. I'm not really marking which screw is which, but I think these are identical. And one nice thing is I have video that I could review if I ever got confused. I don't think that'll happen with this one, famous last words, but photos as you go is really helpful. Even better is marking your screws. I've taken apart things like Apple laptops where you've got to just arrange your screws and label them, or you're doomed, because there's so many different, minutely different sized screws all over the place. In fact, Adafruit has a, we're carrying an iFixit mat that has a white dry erase, like a board type of marker with it, so that you can, and it's magnetic, so you can set your screws down and mark them. Okay, so looks like this is a nice soft plastic here, almost like a HDPE, is that what we call it? Like a milk jug, milk carton. That's nice to work with. Okay, so we've got a speaker here, which I think I will actually remove just to get this out of the way. So I'm going to, again, take a little picture. Yeah, oh good. I'm starting to think maybe it's one motor and just incredibly clever mechanical engineering going on, which will make it harder to do something with 2 servos. But janky is going to be the key here. And speaker. I should really run it in this state. I bet he looks really cool, actually. Before we go any further, I'm just going to clamshell that back together. Let's put the batteries in and run him naked T1000 mode. All right, that's enough of that. Okay. It's instantly cooler, right? You could just go buy these, take the skin off, and resell them on Etsy for double, because it's so creepy. Who doesn't love it? Oh yeah, Andy Calloway says I should paint it silver. That would totally give us the appropriate look, right? Okay, so let's get that speaker out of there. Turn this fan back on. It's voila. So here's our, let's zoom in a bit. Let's see what we're looking at. Here's our board. It is the TPDRQC S16 board. I'm going to put on a magnifier and see if I can read the chip on there. No, that's too tiny. Well, it's some little tiny microcontroller that has a PWM1 and a PWM2. They've marked a battery, the button, so B plus, B minus key, MO, SPK. So there's a speaker out and probably a little amplifier. And MO might be the motor, and there's a bunch of test points. Yeah, there's a lot of test points on there. That's kind of nice. So let's look and see. Can we tell what the mechanism does? This just go freely? I think it was just getting caught on stuff before. Yeah, so something drives that. There's a couple little leaf switches here. So I'm thinking a cam, when it goes in those little up and down positions, is being read. So there's a switch, this purple switch here, purple wired switch here, and the brown wired switch here. So it might even be that it just reverses directions, and the cams are clever enough to do a raise the arms motion. Yeah, I'll bet this little, all right, let's try to see. Can we pull you out? What's going to happen? How far will you fall apart if I try? Okay, I think the legs are on a post that the back is actually connected to. Okay. I think it's just a little hot glue, or yeah, just a little glue holding that. Okay. So that's a miracle that that all stayed together that much. Hey, there's a little gear wheel with a fan belt, a little rubber belt there. So if anything is making him tip back and forth, it's just the weight being offset, I think. Oh, it's that. Yeah, okay. So, sorry, I'm very zoomed in. I forgot. So as the arms move back and forth, you can see this little... Oh, and now it stopped doing it. Yeah. So do we have to raise to get back to that? Okay, it's that. These kind of pull apart. Yeah, so arms moving back and forth are causing this little slight eccentric motion here that wiggles it on the hips. And there's a little nub there that's falling. There's a lot of lubricant in here to keep the friction low. Yeah, there's there's one motor in there. Not surprising, actually. All right, so probably, I'm just going to guess, I will be hacking this thing into I'll be hacking a lot out of here to just control 2 motions with 2 servos. It's not at all how this was designed, but that's okay. It's a good, easy to work with structure, I think, for what we want to do. So what is raising these arms is this little cam here, but something keeps it from engaging right now. All right, let's put the batteries back in and run it. I do like this clever battery arrangement. All right. Yeah, it's just reversing direction. Yeah, you can see the put a dot on it there. I don't know if that'll be captured on camera. Watch this. Reverses direction whenever it raises the arms up. Raises, runs, lowers, runs. Very cool. It stopped doing the back and forth because this little piece came out. So that's what. Back and forth there. Amazing. Yeah, super clever mechanism. And maybe I'll try to document it as I take it apart so we can learn a little bit more about how that's put together. But I'm going to probably totally mangle this thing so that we can see if we can control it with some servo motors. I have high torque ones. We're going to need high torque to do things directly so that we don't have a lot of space to build a whole new mechanism in there. But that's the goal. So bonus goal, reach goal is Lars. That's the right size. That's really funny. Kind of the right size. Totally different anatomy. Lars basically doesn't have legs, but who needs them? We could just reroute power and not worry about those. Probably use different power anyway. All right. So there's a look inside of our cheapy Animatronics. Impressive low-cost build. Like I said, these are like $25. I'm sure you can buy them way cheaper from AliExpress or something like that. But that is going to be the fun project there, and hopefully have something ready for the holidays that can be a little DIY one. We could do our own sound and stuff like that too. But I think the first goal will just be the motion. Try to puppeteer that motion. Okay, let's see what else is going on. I think we're getting close on time. I want to just remind you again, we've got Animatronics as our coupon code today. Since I like doing a small CAD segment before I go, I will show you a brief one that I think is helpful, and that is just how can you get some reference geometry into your 3D scene if you're building some real-world enclosures and that kind of thing. So what I'll do is actually go back to the browser here. If you go to Adafruit's GitHub, github.adafruit.com, and search in the repositories for the word CAD. You'll see the Adafruit CAD parts repository. When you get there, it's just going to be a big list of all of the many, many hundreds of CAD parts that we have. I searched in here for Feather RP 2040. That's what I want to build this around. And that brings you to that, if you click on that link right there, that'll bring you to this page. And in here you'll see, this is Pedro Ruiz, committed this May 10, 2021, and there are 4 files in here. There's a Fusion 3D model, there's a step file, which is an exported NURBS and solid parts file, which is usually my preference to grab that. There's a more baked polygon version, which is the STL. That's the one you usually want if you're going to 3D print it. And then there's a GIF to show you what it looks like. Super great. These are amazing to work with. Usually, the Ruiz brothers build these based on the Eagle model of the footprint, so they're accurate dimension-wise, which is the best. And if I go ahead and click on this step file here, I can view the file, which you can't in a browser, but that's okay because all I want to do is hit the download. So download raw file. You can also download the whole library if you want, or just that folder. But however you want to do it, you can get that file, and then we can drag it in to our modeling software. In this case, I'm using Rhino, and I've put that on its own layer just to be able to hide it there. So there is the model file. It's kind of grouped together, but we can dig into that group if we want to do something with an individual part. A little easier to see what we get. So highly accurate. It's got the dimensions for the holes, which is what we care about, the placement of jacks and buttons and things like that, which is helpful if we're modeling around something. And if we look back at the case builder thing that I was working on, let's, you can see here is actually built a feather-shaped board using my parametric modeling nodes here, but we can go and adjust to suit whatever thing we're making. But in this case, I've gone ahead and built that the size of the feather. I'm just going to lift the feather up off of my parametric board here, so you can see that. Let's go back to a shaded view there, and if you look at, let's go to the version that has the holes cut out. There's my little foundation, which is essentially the same size as the board footprint and the holes with nothing else. So I can use that as a stand-in if I need to, or I can use that as the starting point for offsetting curves, extruding out a box, cutting off a lid, that kind of stuff. So that's where we'll continue with that. But I just wanted to show you what the process is for going and grabbing the geometry. If it's an Adafruit thing, it's probably there. If it is something else that's fairly standardized, if you need to get a servo motor, for example, you can probably go to GrabCAD or somewhere else on the internet. Maybe we'll do that in the future. Go grab that model, bring that in, and verify the dimensions with a data sheet, and then you can start modeling your thing based on that. So that's the simple tip of the day, is just how to get reference geometry that you can hang your hat on and make proper dimensioned stuff in your 3D modeling or CAD package. All right, I think that's going to do it then for today. Thank you everyone so much for stopping by. Last reminder, if you want to buy some stuff at the Adafruit shop, Animatronics will be your coupon code for the day. Tune in for all the other live streams and content that we've got on the various Adafruit channels. Just check the blog, check the live broadcast chat and live broadcast announce pages. We'll see you next time. Thanks everyone for Adafruit Industries. I'm John Park, and this has been John Park's Workshop. Bye-bye.